Hello friends, today again we'll be solving a question related to signal system and involving a difference equation. So the question goes as a system is given to us and its difference equation is given yn equal to a y n minus 1 plus b x of n, and we need to determine the value of b in terms of a such that sigma n equal to minus infinity to infinity h of n equals to 1, where h of n is the impulse response. Okay, so here we have been given the impulse response as h of n, and we need to find b in terms of a such that this condition gets satisfied. So how do we proceed for this problem? So let us first try to find out h of n, or rather h of z, such that we are able to correlate it with h of n. Okay, so let us proceed. So what we will do it first, we'll write the difference equation as it is. Okay, and once that difference equation is written, what we can do is we can take the z transform. Okay, so once we take z transform, so y of n will turn to y of z, and here we can use the property of z transform, and there's a delay of 1 unit, so we get z inverse y of z. Okay, plus b x of z. So this is what we get. Now what we do is we try to separate the y terms and x terms. So we take the y terms to the left hand side. So what we get is this thing. Okay, now what we can do from here is we can take the y z terms common. Okay, so y of z is into 1 minus a z inverse is equal to b x of z. This is what we get. Now what we can do is we can now take the ratio of y of z over x of z, and that comes out to be b over 1 minus a z inverse. Now this is what we have achieved from our difference equation. Okay, now what you can see is this is nothing but h of z, or the impulse z transform of the impulse response. So let us now write it as yz over x of z is equal to h of z, and this is now b over 1 minus a z inverse. Okay, the one we have calculated earlier. Now what you can do is you can directly use the definition of z transform definition for h of z. Okay, so for h of z, if you write the definition, what it will be, it will be n equals to minus infinity to infinity h of n z power minus n, okay, equals to b over a z inverse. Now this is by definition. Okay, this is by definition of z transform that we are getting. Now what we can do is we can notice one thing here. We can notice that if I put z equals to 1, okay, then I get sigma n equal to minus infinity to infinity h of n, and which is given to me as 1. Okay, already. So what I can do is I can then be able to relate b with a. Okay, so what I do is I put z equals to 1. Okay, so when I do that, what I get is n equals to minus infinity to infinity h of n, and the z is 1, so it does not matter, is equal to b over 1 minus a into 1 power minus 1. Okay, this is what I get. Now this is already given to us in the question. This is given as 1, so it is b over 1 minus a. Okay, now what I can do is now I can simply relate b with a, and it is b equals to 1 minus a. So this is how I can relate b equals to 1 minus a when the condition is given. So option C is the correct option. So option C is the correct option for this, and this is how you need to solve problems related to this difference equation. Okay, so thanks for watching.